Hello guys, my name is Mohammed Sultan and I'm here to design some finite automatas using this automation simulator. In this I can design DFA, NFA and PDA. But before that I need to design the language. So the language that I'm using for this is L equals A power n B power n. So for NFA and DFA, I can't check if number of A's is equal to number of B's because it doesn't have any memory. So it is impossible for me to create a language of A power n and B power n. But what I can do for NFA and DFA is I can create a language of L equals A power n and B power m, in which L and m greater than or equal to 1. So let's start it. So for DFA, have to add a state, and while reading A I'm going to S naught, and I'm going to read n number of A, and when I'm C B, the state changes from S naught to S1, and I'm going to read n number of B's, and S1 is my final state. I can just test this by giving the accepted language as AA, BB, AAA, BBB, and it can even accept not equal number of A's and B's. So we can give A, BB and AA, BBB, and the things that will rejected by these finite automatas are like an empty string, or just B, or just a string with A, or BBB, AA, and something like that. And let's test this, and you can see all the test cases are passed. And next we go for NFA. Designing NFA is similar to DFA, which is like this. I'm reading A and going to S naught. I'm reading B and going to S1, and at S naught I'm reading n number of A's, and at S1 I'm reading n number of B's, and this is my final state. And let's test this out. Since it is not non-deterministic finite automata, it doesn't matter if A comes first or not. So the BBB tests the BBB and empty string will be accepted by this finite automata. And you can see all test cases are passed. And for PDA, we're going to do the A power n, B power n language. So we add a state, and here you can see the first input is what I'm going to read, and the second input here is what I have to pop from the stack, and the third input is what I'm pushing in the stack after I'm reading this. So at first I'll just set the top of the stack, which is Z. So I'm reading epsilon and pushing this pushing capital Z to the stack. And at the second state, I'm going to read A, and I'm not going to pop anything, but I'm going to push A. Say this, and I'm going to push n number of A's into the stack. And at the next state, I'm going to read B, and I'm not going to push anything, but I'm going to pop out A. So for n number of B's, I'm popping out n number of A's. And at the last step, I'm going to pop the Z, the top of the stack that I've added first. So if I read epsilon and pop this out at the last step, that means number of A's is equal to number of B's in the given string. And this is the final state, and here this will not be passed. So the number of A's and B's should be equal for this finite automata to get accepted. So A, B, B, this will pass, and anything other than that will be rejected, like A, B, B, A, B, B, and string, or just B and just A's. It's not passing. Let me check this out. I'm reading A, and I'm pushing A into this, and here I'm reading A and pushing. Same thing. I'm reading A, I'm reading B and popping off A's. Oh no, I forgot this self loop. So I have to read B here and pop off n number of A's, n number of A's for this, and now this will work. And you can see all the test case works. And that's it. Thank you for watching.